Good afternoon, guys. So this will be my first video on Laplace transform. This transform is used in what? In solving differential equations in engineering, in different applications of mathematics. So this topic, you need to understand how to get the Laplace transform of different functions. So starting with the topic, a transform is defined as the integral of a function of time, a function of t times e raised to power minus st, taking the integral from 0 to infinity. The s here is just a constant and it's chosen in such a way that it is greater than 0 and making sure that this function here, the function here approaches 0 as t approaches infinity. So that is the definition of Laplace transform. So it's an integral that acts on the what? On the function of t, and this tool is used in what? In solving very hard differential equations in mathematics, mostly used to solve differential equations of constant coefficients and other forms of differential equations. So to start with this, let's know how to use the transform to transform some different simple elementary functions. Elementary functions we have one is when you have a function that is equals to what? A constant. So let's assume we have a function equals to a constant. What is the Laplace transform? We can also have another function where we have t raised to power n. For example, that is also another what? That is also another function of t. Function of t can be anything. Another function of t can be, for example, your trig functions like your sine t and cosine of t. Different functions of trig can also have it, but the most basic ones are the ones I'm writing. We can also have the hyperbolic functions, like when you have something like this and you have something like this. You can have a lot of functions, different types of functions. You can also have exponential functions. Let's say e raised to power at, for example. You can also have another type of function. Let's say you have e raised to power at cos kt, and so on. Different functions you can have where you can use your what? Where you can transform it regarding the differential equation I'm dealing with. So I'll start with the first one, which is very, very easier. Find the Laplace transform of f of t. So we are asked to find the Laplace transform of this function. Now, the k here is a constant. The constant here serves as a constant in what? In the function of t. So to find that, we use the definition of what? Of Laplace transform. So taking that, we know the Laplace transform of a function is equals to this e raised to power minus st f of t dt. That is the Laplace transform of a what? Of a function. From here, then that means my Laplace of a constant will be equals to the integral from 0 to infinity of e raised to power minus st times k dt. That will be the next thing. You can see you have f of t here, you can have it here also. So I replace the f of t by k, which is the question. I place it here. But we know in integration, I can bring out the constant out from my integral. So we can bring the constant out here, and you have this left alone. So from here, you can compute the integral and find your answer. So what we can have here, the constant is outside because the k is outside because it's a constant. You can remove a constant from integral. It doesn't have anything to do with the integral. So to integrate this particular one, we can do it somewhere else here. Let's integrate this alone first. So the integral of this, I want to integrate this. To do this very easily, you can say, okay, let u equals to minus st. Let u equals to minus st. From there, I have to make sure that everything here looks in terms of the u I have here. So from there, I can say my du dt is equals to minus s. And my dt, bringing this here and bringing this here, my dt is equals to minus du over s. Also, we have to check out the boundaries of what? Of the integral. So to replace everything here, I'll say as t approaches u approaches, so you can put the value of t in this minus st minus s times 0, which is equals to what? 0. So that means when t goes to 0, u also goes to 0. I mean, I've get the value of t, I get the value of u when t approaches 0. The same thing also goes with this. When t approaches infinity, what is my u? My u approach something like this. And that is approaches minus infinity. Because this is infinity, and we know from the definition that the s is positive. So the positive times infinity, that is a positive value times minus, and that is a minus infinity. From there, we can then substitute everything in the question. So we are through with that. So everything becomes, this integral alone becomes minus infinity, which is this. You can see, yeah, t is equal to 0. Well, t is equal to 0 here, but when I take the value of u also at the same time, since I made this substitution here, the u also goes to 0. But at this side, I made the substitution of t is equal to infinity. And at the same time, as t is approaching infinity, the u is going to minus infinity because my u is minus st. That means here will be e raised to power u. And yeah, my t goes to 0, my u goes to 0. I mean, here is 0. But when t goes to infinity, my u goes to minus infinity, and that is minus infinity. So you, and this dt also changes. My dt here is equal to minus du over s. Minus du over s. So from there, you can bring this. This is also a constant. That is minus 1 over s outside. then you have minus infinity and 0 e raised to power u du. But this is an elementary integral, e raised to power u, the elementary integral, which always, this integral alone itself, without the boundary, is equals to e raised to power u. Are you getting? Then you can put the boundary here will be minus infinity and 0. The integral of this is itself. In fact, the integral of e raised to power x, the elementary function, is itself. Likewise in differentiation also, when you differentiate e raised to power x, differentiate e raised to power x dx, you get e raised to power x. So this particular function in mathematics, when you integrate and differentiate, it remains the same way. So this appears the same way. Then you now put the boundary of this and this. So you can put the boundary here, that will be minus infinity minus e raised to power 0. That all should be there. So from here we can have minus 1 over s, and this means this can be written as 1 over e raised to power infinity. This, I don't want e raised to power infinity, and this can be written as 1. So the reason why this becomes this is because, note, a raised to power minus n is equals to 1 over a raised to power n. So this is in this form, a raised to power minus a power is equals to 1 over a raised to power. Same thing I did here also, that is 1 over e raised to power infinity. And this is a very big number, very big number. So that goes, and when you have 1 over a very big number like infinity, the value approaches 0. So here you have minus 1 over s, this becomes 0, minus 1. And that goes to minus 1 over s and minus 1. This and this become plus 1. So you have 1 over s. That will be the integral of this. So the integral of this, which goes to this, gives us 1 over s. That is the integral of this. But we have to go back to the main question, which was asked already. So going back to the question, I know the question was actually Laplace of a constant, which is the integral of this minus st k dt, which equals to this. But we found the value of this. The value of this. Note, the value of this is equals to 1 over s, which we found here. That means the whole of this will be k times 1 over s, and that is k over s. So that will be the Laplace transform of a what? Of a constant. So we can check out the values, the transform of different constants. For example, we can take the value of different constants. So let's assume I have if, so therefore Laplace transform of k is equals to what? K over s. So that means if I have Laplace transform of 1, my answer will be 1 over s. I don't have to go through these steps over and over again. I have to just generalize it, which I did here. So of a constant equals to the constant over s. That means if I have 1, it will be 1 over s. If I have 2, it will be 2 over s. If I have minus 3, it will be minus 3 over s. And if I have 100, it will be 100 over s. So that is how Laplace transform works for constant. It's the constant over s, which we just derived there. So we're deriving the next one, which is the powers of t. So let me start from this side. Let's find the value of this. The Laplace transform of t raised to power n. Where n to 0. So this is a question we have to find the Laplace transform of this, but it's for only when the number is equals to 0, and particularly the n should be an integer. So let me write it like this, where n is an element of positive integer. Let me say natural number. So your n is an element of natural number. Let's find Laplace transform of t raised to power n. That means I have to find this. T. This is what we have to look for. Find the value of this. Okay, fine. This is a very tedious integral in the sense, this type of integral we use what we call the integration by parts to solve this. But we have raised to power n here. So that takes, if you have raised to power 10, then that means you have to do integration by parts 10 times. But fortunately, this type of integral have a special form in mathematics, which I will change this integral to that particular special form to make our work more easier. So what I'll do here is, I'll choose a variable. Let's say u is equals to st. If my u is st here, then that means my t should be equals to, so I divide this by this, that is u over s. My t will be u over s. Then also we have my du dt. My du dt will be equals to s. And that means my dt will be equals to du over s. So I can change everything in this integral before I do that, I have to take out the boundary of both. So since u is equals to st, so let's check as t is approaching 0. What is my u? That is s times 0, and that is 0. Also, as t goes to infinity, my u is s times infinity, and that is also what? Infinity. So that means it's has the same value. So as t goes to 0, u goes to 0. As t goes to infinity, u goes to infinity. That means the integral remains actually, the boundary remains the same. So this become e raised to power minus u. My st is my u, so it becomes u. My t is u over s, so that is u over s raised to power n. And my dt is du over s. So from there you can have from 0 to infinity e raised to power minus u. Yeah, this becomes, so from indices, this is u raised to power n over s raised to power n, and then you have the u here, c over s here. You can see I did substitution. I have this form: e raised to power minus u raised to power n du x. So